All right, so we are going to go through the answers for problem set number 6, which is on market failures. And I have all of these written out, so we're going to go through each question. So the first question is, identify and explain the two characteristics of public goods and give examples. The key parts to be a public good are excludability and rivalry. So if a good is non-excludable, meaning you cannot prevent people from consuming even if they're unable to pay, then it's going to be public. And then finally, non-rivalrous, meaning one person's consumption doesn't diminish someone else's ability to consume that product. Prime examples of public goods include streetlights. One person using a streetlight to see does not prevent someone else from being able to see using the same streetlight. Additionally, people can use streetlights even if they didn't pay the taxes that contributed to building the streetlight. If a good is excludable and rival, then it is a private good. If it is only one or the other, either excludable and non-rivalrous or non-excludable and rivalrous, it's considered a quasi-public good. Quasi-public good. All right, the next part of this question is asking why the public sector instead of the private sector provides those public goods. And the reason for that is profitability. If a good is non-excludable and non-rivalrous, you cannot make a profit off of these products. And because they're not profitable, the private market is not going to provide them. It would be cost prohibitive for the private market to produce these goods. Free riders would take advantage and use the goods without paying for them, and it would cost money to the producers. Now, there are a lot of types of market failures, but one of the ones that we looked at in depth was externalities, and there are two types of externalities. First, we are going to look at 2A, which is negative externalities. 2A asks you to assume excessively large SUVs include spillover costs that are not borne by the initial consumer, but rather by society. Explain two negative externalities associated with SUVs and who pays the cost. They can result in a ton of externalities. I picked two. The first was air pollution from exhaust and production, and then the other one was wear and tear on the roads from the size and weight of those vehicles. These costs are paid by everyone in society, not necessarily the person that is driving the SUV or producing the SUV. Part 2 is to use a supply and demand graph to illustrate this negative externality. Identify the current price and output and socially optimal price and output. So you can see here I have my axes. I have my price axes and I have my quantity axes, right? My P's and Q's. Now demand is going to be drawn as MSB. This is the marginal social benefit equal to the marginal private benefit equals to demand. And up here I have my two different costs. First I have my private cost. This is the cost to the SUV purchaser and producer, the consumer and producer of the SUV. And then here I have my MSC, my cost to society. If I were to factor in that pollution, and if I were to affect the road condition, include the road conditions, our social cost would be much higher. Okay? So currently our current price and quantity would be here, and our socially optimal price and quantity would be here. I put SO for socially optimal. So you can see that they are overproduced, okay? They are overproduced and underpriced. Ideally, in society, we want them to be priced higher. We want them priced higher and produced fewer to achieve what is socially optimal for society. That is what is true in a negative externality. All right, now we're going to scroll down and look at part 3. All right, using MSB and MSC, explain. Oh, I just said that. There you go. Because MSC is greater than MPC, it's a negative externality. Our social costs outweigh our private costs, so they are underproduced. Because you produce at private cost equals private benefit, they are overproduced. The free market has failed because our socially optimal amount is not being reached. So how can the government fix this externality? here is a graph to fix the externality. We would add a tax equal to the difference between MSC and MPC. So if you find this value, the distance between those two lines, and you add that as a tax, we would be able to shift this curve closer to this curve where we could produce at the socially optimal amount. That would be ideal in order to fix this externality. Now I'm going to move on to positive externalities. Positive externalities are when you have that external benefit that is received by someone in society who did not pay to produce or consume the product. So more parks increase our positive externalities because they can increase property values, lower stress and anxiety of their visitors, and increase air quality or decrease pollutants in the neighborhoods surrounding them. These are all benefits experienced and shared with anyone who lives or visits that park. Using a supply and demand graph, we would graph it like this. So we have, again, our axes, P and Q. Then I have my demand curve, that's a P. My demand curve here, which is my private MPB, my private benefit, not the same as my MSB, what society wants. Society wants more parks, but the private market is only producing a few parks. And there's my MSC, MPC, my supply curve. Currently, we are producing this many at this price. We want this many at this price, right? Socially optimal. So you can see that they are underproduced because we want more, and they're underfunded, underpriced because we should pay more because of the benefits that they would give us. So that is our market failure. It's our market failure. All right, so to correct this market failure, what should the government do? Well, we can either produce these goods as a, sorry, I gotta move the board. We can either produce these as public goods, all right, where they are paid for by tax dollars, or we can subsidize a private firm to provide these parks, increasing their production. So if we subsidize them, that is this graph here on B4, and that subsidy would shift our MPC curve to the right, decreasing the cost, the private cost, and increasing our production. So we could reach that socially optimal output at a lower price, right? Giving the people what they want at a lower price. So that would be the way we would correct that externality. Now I'm going to move on to the next question. Question number 3. Question number 3 is about antitrust policies and why we have antitrust policies. You guys learned about these trust busters back in American government, or not American government, maybe that, American history last year, but now we need to look at them from the perspective of controlling monopolies. So an antitrust policy is designed to promote competition in our markets, preventing monopoly power from forming. The goal is to achieve allocative efficiency. If we are achieving allocative efficiency, that's where price equals MC, okay? Which is not found in a monopolistic market, generally speaking. Perfectly competitive markets are price takers and must produce and sell at the allocatively efficient point where P equals MC equals MB. That is when we're perfect, okay? Monopolies, on the other hand, produce where MR equals MC and set their price at their demand curve so that output is not where MC equals D, and they have created a deadweight loss to society. If there is a deadweight loss, they are not allocatively efficient. Okay? Allocative efficiency means that we've maximized our consumer and producer surpluses. So if there's a deadweight loss to society, obviously that is not true. So they cannot exist simultaneously. So if our government's goal is to achieve allocative efficiency, we should subsidize the monopoly because taxing them would further increase prices and limit their output. So if we subsidize them, we can get them to move. Where's my graph? Oh, I had a graph of this and I don't know where I put it. All right. if we subsidize the monopoly, we can get them to increase their production output, and that would make us closer to our socially optimal production point, because we would not be limiting output and they wouldn't be charging the consumers the higher prices. All right. Now, the next one is taxes, the 3 types of taxes. We talked about these in class, and we talked about M&Ms. So the 3 types of taxes or tax systems excuse me, are progressive, proportional, and regressive. Progressive taxes take larger amounts of money from the wealthier people. As you progress up the income ladder, you're paying more and more. Proportional taxes tax everyone at the exact same rate, so everyone will pay the same amount. Regressive taxes take a larger portion from the poor. Examples of these: progressive is income tax, where in the United States, the wealthier you are, the higher rate of income tax you pay. Proportional taxes would be when everyone pays the same 20% or whatnot. Property taxes are an example of that here in Palm Beach County. Property taxes are at a certain rate. And then regressive taxes take a larger portion from the poor. For example, sales tax or sometimes excise taxes. Remember I told you if gas were $5 a gallon, you would probably care a lot because your income or your hourly wage is closer to minimum wage. But when Bill Gates pulls up to fill up his tank, he doesn't really care if gas is $5 a gallon because he is wealthier. That would be a regressive tax. Progressive taxes, on the other hand, if we tax our top earners 50 or 60%, you don't care because as a student, you're probably not paying income tax at all. Bill Gates would care a lot because he would be in that category. That would be a progressive tax. All right. 4B, Lorenz curves. This is how we graph income inequality. Now, when we're looking at the Lorenz curve, the question is asking you about the distribution of income. Oh no, that's that was 4A. 4B, the average family income and why it is misleading looking at a Lorenz curve. Well, now remember, the average is misleading because of outliers. One person making $1 billion is going to drag up the average, but that doesn't mean the wealth is spread between everybody. So you can't use an average as an accurate measurement. And that's why the Lorenz curve is good, because it shows you the different distribution of income for the population. So on this curve, on your vertical axis, we have over here our percent of money, and down here we have our percent of the population, and we have this 45-degree angle line. That is the line of equality. On the Lorenz curve, the closer we are to the equality line, the more equal the country. The fatter this line is, the more unequal the country. All right? So when you're looking at this curve, if the line looks like this, it's saying that this percent of the population only has this percent of the wealth, okay? So here, if it's equal, this percent, 50%, 50%, all right? You're measuring here. The Gini coefficient is measuring the area of this circle, or semicircle, this moon shape, over the area of this whole triangle. Okay, that's how you find the Gini coefficient. So the Gini coefficient, the smaller the number, the better the country. And the bigger the number, the more unequal. Okay, so if the Gini coefficient is a very small number, income inequality is very small in that country. And if it's a very large number, it's very large in that country. All right, so now we're going to look at 3 different FRQs from the actual past AP Micro exams. And we're going to, on this topic, and we're going to look at how to properly answer them. So the first 2 questions are from 2002, and then the other one I believe was 2005, but I can't remember. Okay, so the first 2002 exam. Here is a graph. You have your P and Q, and you have your optimal quantity and price labeled, and you have your MSC and your MSB curve. So you have social cost and social benefit. Now, in some cases, the market fails to allocate resources efficiently. So A Assume this chemical industry is polluting the air. Using MSB and MSC analysis, or MPB and MPC analysis, explain how they are misallocating resources and identify a policy or action the government could take to correct this market failure. So here is our answer. I redrew the graph so I could look at it while I was answering. So 5.1. The chemical industry is only considering the private cost and private benefits they're receiving from their good. So they are going to be overproducing and undercharging for their negative externality, inducing product as MSC is greater than MPC. So if they are only considering the private cost and benefits, their private cost would be here, MPC, right there. So they would be producing Q1, P1, all right? They'd be producing right there. So that means that they are undercharging and overproducing. The government could tax this industry to shift their curve to the left. That way it would be more in line with the MSC curve to correct this market failure. That's what they are looking for from you. Now for 2B, they want you to look at your MSB, but think about it from a different perspective. Assume it's difficult to exclude non-payers from enjoying the benefits of national defense. So now we're looking at the same graph, but pretend this is national defense. They're talking about positive externalities here. So go up, scroll up. There we go. All right. So identify, use marginal benefit and marginal cost analysis. Explain how the private market will fail to produce at efficient levels of national defense. So I wrote national defense is good with positive externalities because MSB is greater than MPB. The social benefit, the societal benefit, is greater than the private benefit. And it experiences free riders. Because of this, the private market would produce too little of this good. Free riders, the people who use it without paying, exist. So the private market is not going to produce because they don't want free riders. There's your problem. So how do we fix this? Well, two different ways. You could either write, the government must provide defense as a public good to correct this market failure, or else subsidize a private firm to provide it. They would have to incentivize private production of this product. Okay, the next question that we are looking at is also from 2002, AP Micro, FRQ. This is, the government has decided to take action to reduce pollution caused by the chemical industry. And this industry is composed of profit-maximizing, perfectly competitive firms. That means you have Mr. DARP equals MC, just so you know. Now 2A, identify one policy that the government could implement to reduce pollution, explain the effect of the policy on all of these things, and on efficiency. So let's go back to here. All right, so here we go. A policy that they could implement to reduce pollution would be a per unit tax on the pollutant. Remember in class we said that per unit taxes are what you have to do to be more effective. The lump sum does not shift the MC curve, so quantity stays the same when you do a lump sum tax. Per unit taxes are variable, so that makes the marginal cost curve shift, and that would be what we would want to do. Part B, this would increase our marginal cost, decreasing our output and increasing our price. Okay, so there is the shift. Now we would, I'm going to graph that real quick just so you can kind of see. You have P and Q, all right, and you have MC, and you have Mr. DARP. Okay, so originally we were producing right there, okay? Now, if we do a per unit tax, we're going to cause marginal cost to shift upwards. So when we shift this upwards, here we go, okay? That means we are going to have a new production quantity here, okay, causing our quantity to decrease our output, all right? And then in the long run, this is going to cause our prices to go up because on our market graph where we have supply and demand, right, if these firms are incurring a loss, supply is going to shift to the left, and we're going to find a new Mr. DARP. Okay, so there is our graph. Okay. Now, finally, part C. This would increase our efficiency, all right, for society, because firms' MPC curve would increase to society's MSC curve, bringing our output to the socially optimal level. That's what I had just graphed if I didn't erase it. Remember over here, I had our supply and our demand. This was going to be our MPC, and this was MSC because of the negative externality. So when supply shifts left, that means we're going to be closer to socially optimal. Remember, socially optimal is what society wants, when society's costs equal society's benefits. All right, so that would be answers to 2 of the shorter FRQs, because there's always 1 long and 2 short FRQs on the 3 FRQs for the exam. The next one we're going to look at is an example of a long FRQ, one of the longer FRQs. And you can see those are worth substantially more points than the other ones. So this one gives you the big graph. I'm pretty sure you had this graph in a test this year. I think I used this one, but I cannot remember, to be quite honest. So here is price and quantity on our axes. You can see that we have a perfectly elastic MSC, perfectly elastic MPC. We have demand equals MSB, and we have MR. We know that this is going to be an imperfect market, a monopoly or monopolistic comp, because of our graph. All right, and so we are going to go through and answer some questions. The production of good X creates an externality. Obviously, these are not the same. Oh, I'm not coloring. These are not the same. These are different. So that's our externality right there. The following questions are based on the graph, which shows the MR, MSC, MPC, MSC, MSB, and whatever. All right. 1A, is this externality positive or negative? Explain. If you only pick one and you do not explain, no marks for you. You have to explain. If it says explain, you have to have a full sentence. This is a negative externality, all right, because MSC is greater than MPC. So it's a negative externality because MSC is greater than MPC. Using the labeling from the graph above, identify the socially optimal output and explain how you determined this. Socially optimal, what society wants. Society. Find the intersect. It's right here. So socially optimal output would be where MSC equals MSB, which is Q2. Q2. All right. Now the next question says, I have to find the question because I can't read it on here. Suppose this is produced by a profit-maximizing monopoly. Answer each of the following. C1. Using this labeling, identify an unregulated firm's output and explain how you determined. If they are a monopoly, unregulated, profit maximization would be MR equals MC. So here's our MR curve right here. Okay. Here's our MC curve right here. So they are going to produce at MR equals MPC, Q1 units. Okay, Q1 units. Now C2, to produce the socially optimum output, should the government tax or subsidize this firm? Society wants Q2. Society wants over here. So how do we get there? How do we get them to make more? If we want them to make more, the government will need to subsidize this firm. Okay? So now the follow-up question is C3, calculate the dollar value of that per unit tax or subsidy. Well, what is the MR for the firm? If they produce Q2, their MR would be $4. And at Q1, their MR is $7. So how much do we need to pay them to get them from here to here? 7 minus 4, $3. Okay? $3 per unit. So now, before I move on to finish this question up, I'm going to show you what my answers look like on my answer sheet. Okay. Okay, so this is where I want you to see exactly what I wrote to get the points for this answer. So you can see I wrote A, this is a negative externality because MSC is greater than MPC. B, socially optimum output is where MSC equals MSB, so at Q2 units. Unregulated monopolies will produce profit maximize at MR equals MPC, which is Q1 units. To achieve socially optimal output, the government would need to subsidize this firm, and the subsidy should be $3 per unit. And then I showed my math right here. I wrote at Q2, MR is 4, MPC is 7, which would be a $3 loss. So that $3 loss per unit to recoup from the subsidy. All right, so now to finish this up, the last question is asking you to suppose that good X is produced in a perfectly competitive industry. Answer the following. Before I do that, what you have to look at this graph and remember that D does not equal MR. That means imperfect. So if this were a perfectly competitive market, we would need to redraw this here and say D equals MR, because remember Mr. Darp. So now you have to pretend like that other MR curve doesn't even exist. So now for D part 1, using the labeling from the graph on this graph, identify equilibrium output in the absence of regulation. So now the answer is going to be MR equals MC, where MR equals the marginal private cost. So our new output would be Q3. So D1 would be, in a perfectly competitive industry, MR equals D. So output would be MR equals MPC equals D, which is at Q3 units. Now to produce the socially optimal output, indicate whether the government should tax or subsidize the firm. Well, socially optimal is still where MSB equals MSC, which is right here. So right now we have too much. If we have too much, how do we stop that? We have to tax them. So again, to get to socially optimal, the government should tax this firm. Now, how much should the tax be? Well, the tax is going to be the difference between our MSC and our MPC. So 12 minus 7, which is a $5 tax per unit. Okay, so now I'm going to show you how I wrote out my answer so you would see what it looks like on my answer that I turned in, if the screen doesn't freeze. All right, so here you can see exactly what I wrote. In a perfectly competitive industry, MR equals D. So output would be where MR equals MPC equals D, which is at Q3. And we should tax this firm per unit tax of $5. All right, that ends Unit 6.